We're looking at a method for approximating or estimating the circumference of a circle. We're starting off with a circle that's about 117 millimeters in diameter. I can draw an equilateral triangle inside that circle, and the perimeter of the triangle is going to be similar to the perimeter of the circumference of the circle. It's not that close, but it's a starting point. So an equilateral triangle that goes inside that circle would have sides that are 10 centimeters or 100 millimeters in length. So for my approximation of the circumference of the circle, by using the perimeter of the triangle, I would have 3 times 100 because there's 3 sides in the triangle. So that's 300 millimeters is my approximation for the perimeter of the circumference of the circle. Not a great approximation, but it's a start. Now I'm going to take that same circle with the triangle inside. I'm going to take one of the edges and I'll divide it. So right here in the center at 50 millimeters, I'm going to do a vertical line straight up from that. So I'm going to take my ruler and I'm going to transfer that halfway mark up to the top of the circle. Then I'm going to join that point to each of the corners, so I'm making a new triangle. This one's no longer equilateral, but I've made a new triangle, and if I did that on all of the sides, you can see that now I've got a hexagon shape, and the red hexagon is a much closer approximation of the perimeter of the circle from my hexagon shape. And if I measure them out, it looks like it's about 5.75 centimeters or 57.5 millimeters. And in this case, there are 6 of those, so I've got 6 times 57.5, which is 345 millimeters. That's a better approximation than when I was using the triangle, but I can repeat this process. If I take 57.5 and divide it by 2, I end up at 28.75, so that's approximately about here. So that's approximately here. And I extend that line perpendicularly out to the perimeter, and again, form a new triangle. And I can continue that all the way around as I've done before. So it's fairly clear to see that now the green shape is a lot closer of an approximation to the perimeter of the circle than the red shape was, and which was much closer than the blue shape. So I'm going to take my ruler and measure the length of those green sides. And it looks like each green side is approximately 3 centimeters or 30 millimeters, and there are 12 sides. So I end up with an approximate perimeter of 360 millimeters. So you can see that I could continue the process of making smaller and smaller triangles in the remaining space. With the resolution of my screen and the size of the circle, that becomes very hard to do. However, if I went through that process, you can see that as I did more and more sides, the shape gets closer and closer to a circle, which means that the size that I'm measuring is going to be a much closer approximation to the perimeter of the circle. So the triangle was a very rough approximation. The hexagon, the red shape, was a closer approximation. The green shape is getting to be a much closer approximation of the perimeter of the circle. If I want a better approximation, I can keep working with triangles. So I'm going to this time work with isosceles triangles, so triangles that have 2 sides equal. And I'm going to take this 10 centimeter length or 100 millimeter length, and I'm going to divide it in 2. And I'm going to transfer that mark up to the perimeter of the circle. Once I've done that, I'm going to form a new triangle. And you can see that I can do that all the way around with the other 2 triangles as well. And you can see that the red shape is a closer approximation of the circumference of the circle than the blue triangle was. We can continue to repeat that triangle making process. If again I divide one of these lines in half, and form a new triangle in the remaining space. I can do that all the way around. And clearly the green shape is a better approximation of the circumference than the red shape and the blue shape. We could continue to repeat this process until we basically couldn't work anymore, until all of the numbers and until all of the lines are too close together to draw any more triangles. But when we get to the smallest triangles that we can make and measure the length of each one of those triangles, because the edges will be the same in each triangle, Then we can multiply that by the number of edges, and that will give us our total perimeter. The perimeter of that shape will be a very close approximation of the circumference of the circle.